Hello future doctors, how are you to all? Now we are going to discuss important numericals about dual nature of radiation and matter. That question will help you to getting best rank in this year in NEET exam. I will solve 5 questions in this video. You will try to solve at your home. If you have any problem, so you can make a comment below the comment box. I am always ready to help you. So let's go to solve some numerical. Now we are going to solve question number first from the chapter dual nature of radiation and matter. This question is a very important question. So please make a focus on that board. First we will read this question carefully. Question number first. A beam of cathode rays is subjected to cross electric and magnetic field. What they are telling? A beam of cathode rays is subjected like that. They are just crossing electric field and magnetic field. The fields are adjusted such that the beam is not deflected. It means both field, magnetic field and electric field, are adjusted like that. They are not showing the deflection of beam. Okay. The specific charge of the cathode rays is given by. What is the value of specific charge? If capital V is the potential difference between cathode and anode. If capital V is the potential difference between cathode and anode. Okay. Now, how you can solve this problem? First, you will mention given point. What is given? So here given electric field and magnetic field. So you can write electric field denoted by capital E, and second condition magnetic field denoted by capital B. You know very well. So one thing that, please remember one thing, that if they are having an electric field, so due to electric field there will be electric force. So there will be one force that you can say electric force, you can consider. Similarly, if they are having a magnetic field, so due to magnetic field there will be magnetic force. Okay, so you can mention FB. Force due to electric field, force due to magnetic field. Okay, so now what is the value of this force due to electric field? So it will be E, capital E. Small e, charge on electron, capital E, electric field. Similarly, force due to magnetic field, you can write here capital B, E, small v. Capital V is a magnetic field, E is a charge on electron, small v is the velocity of electron. That is the confirm. Okay, now how you can solve it? You will solve. There is a given one condition. Field are adjusted like that beam is not deflected. If beam is not deflected, so remember one point. If beam is not deflected, so you can write force on electron due to magnetic field will be equal to force on electron due to electric field. Both will be equal. This condition you will apply there. Okay, so now you can write the value. What is the value of FB? FB having this value, BEV is equal to, what is the value of FE? FE having this value, E, capital E. It will be cancel it. So BV will be equal to E and small v will be equal to E upon B. This one having a first condition. Now for second condition, if capital V is the potential difference between cathode and anode, I am writing here, if capital V is the potential difference between cathode and anode. Cathode and anode, potential difference V. So you know one thing that the energy of electron due to magnetic field, you can write here mv square will be equal to energy of that electron due to electric field. both will be equal here. Okay, yes or no? You can adjust this value you can just say here, you can just write here, you can adjust this value you can adjust like that you can just keep here half v square upon capital V is equal to E upon M. So you can adjust like this, okay, this value. Okay, now you can write here, what you can write, E upon M is equal to half multiple 1 upon capital V multiple, you can write the value V square. Okay, so now E upon M is equal to half multiple 1 upon V multiple, you can put the value of small v from equation first, so you can write E upon B whole square. Okay, now you can adjust, E upon M will be equal to 1 upon 2, you can write V, and you can write E square upon B square. Okay, for like this situation if you want to write, so you can write E upon M is equal to E square upon 2V B square. E upon M is equal to capital E square upon 2 capital V B square. Which option is correct you can see in given option. So you will see option A is the right answer of this problem. You can denote it by capital A this answer also. Okay, so E upon M is called specific charge. E upon M is called specific charge. So this is the value of a specific charge. So like this you can find this given situation will help you to finding the right answer. Okay, if you will not mention like this situation, so definitely you will stuck. Okay, first if you are not in proper practice, so first you will follow like this method. If you are in practice, so directly you can solve, so that directly if you will solve, so definitely that you can just consider like as a short trick. Okay, so now we are going to solve second numerical. Okay, now we are going to discuss question number 2 from the same chapter, dual nature of radiation and matter. This question is also important question, so please make a focus on that board and just read this question carefully. Question number 2, a photoelectric emission process from a metal of work function 1.8 electron volt. The kinetic energy of most energetic electrons is 0.5 electron volt. The corresponding stopping potential is, what they are asking, what is the corresponding potential? There is a given 4 option. Which option is correct? We will see after solving this problem. Listen one thing, that first you will mention what is given here. Given that work function given, so you know very well work function basically denoted by phi. So phi given 1.8 electron volt. And second things, most energetic electron is given 0.5 electron volt. It means there is a given maximum kinetic energy, that is called maximum kinetic energy 0.5 electron volt. Okay, and they are asking what is the value of corresponding stopping potential. So corresponding stopping potential we need to find. How you can solve this problem? Main question is that how you can solve this problem. So you know very well the relation between maximum kinetic energy and stopping potential. So you will just write here one relation, maximum kinetic energy is always equal to the EVS. So this one having a relation between maximum kinetic energy and stopping potential. So this formula you will apply directly. So you can just see here what is the value of maximum kinetic energy, 0.5 electron volt. So you can write 0.5 electron volt equal to the EVS. So E will be cancelled. So finally 0.5 V is equal to VS. So VS is equal to 0.5 volt, you can write like this. So this is a final answer of this problem. So which option is matching with the this answer. So you can see here option number D is the correct answer of this problem. If you are asking why we are not using this value work function, so there is a no need about work function because here is the only relation like this. So you will apply this relation and you will put the value, you will get your answer. Now we are going to discuss question number 3rd. Now we are going to solve question number 3rd from the same chapter, dual nature of radiation and matter. So this question is also important question. So please read this question carefully. After that we will solve. Okay. Question number 3rd. A 5-watt source emits monochromatic light of wavelength 5000 angstrom. When placed 0.5 meter away, it liberates photoelectrons from a photosensitive metallic surface. When the source is moved to a distance of 1.0 meter, the number of photoelectrons liberated will be reduced by a factor of. What they are asking? They are asking what is the value of number of photoelectrons. So how you can find the answer of this question? Because here given 4 option, which option is correct we will see after solving this problem. So first point we will write here, given that, what is the given? First given 5 watt, it means power of the source given 5 watt. Next wavelength, wavelength given, how much given? Lambda is equal to 5000 angstrom given, and place the distance, this one and this one, two distance given. So you can write d1 is equal to given 0.5 meter and d2 is equal to given 1.0 meter, two distance given. Okay, so now you know the relation between that intensity of the light, power and distance. So they are having a one relations, I am just writing here, they are having a relation like this. Intensity of light is equal to P upon 4 pi d square. This one having a relation. It means formula you can consider. Okay. So if you are writing intensity of first condition, so you can write P upon 4 pi d1 square. Okay. Yes or no? Small a you can say. Similarly, if you are writing I2 is equal to, so you can write P upon 4 pi d2 square. This one say B. Yes or no? If you are writing the ratio between I1 upon I2, so you can write, whenever you will just solve it, so you will get d2 square upon d1 square. Yes or no? So this one you can say second. So now I am going to solve this problem. So how you can solve? So you know this relation I1 upon I2 is equal to, I can also write d2 over d1 whole square. So you know the value of d2, you know the value of d1. So you can just write here I1 upon I2 is equal to, what is the value of d2? d2 having value 1 divided by, what is the value of d1? d1 having a value of 0.5 whole square. Okay, now you can write I1 over I2 is equal to, you can write, you will remove this decimal, it will come 0. So 5 2 ja, so it will be 2 upon 1 whole square. So you can write I1 over I2 is equal to 2 2 ja 4 upon 1. So you can just write I1 is equal to 4 times of I2. So 4 times of I2 is showing here after solving this problem. So here is a coefficient of I2 is a 4. So 4 is the right answer of this problem. So that is the number of photoelectrons that is liberated. Okay, so that is a 4. So which option is correct? Option B is the correct answer of this problem. So you will just follow like this method. You can apply this formula and directly you can get your answer. If you know formula directly, so you can apply. If you don't know, so first you will mention the all situations. After that you will search the formula, then you will apply, and after that you will do practice twice and thrice time. So now we are going to discuss next question. Now we are going to solve question number 4 from the same chapter. This question is also important question. So please read this question carefully. Question number 4 is, the work function of photosensitive material is 4.0 electron volt. The longest wavelength of the light that can cause photon emission from the substance is. So they are given 4 options. Which option is correct? We will see after solving this problem. So first you will mention what is given. Given that work function given 4 electron volt. Work function denoted by phi given 4.0 electron volt. And they are asking longest wavelength. So we need to find lambda naught. That is a longest wavelength. Okay. So how we can solve this problem? Whenever you will find like this solution, so you will apply this formula to finding longest wavelength. Lambda naught is equal to hc upon phi. Lambda is denoting that longest wavelength, h having a Planck constant, c having a speed of light, phi having a work function. So you know the value of Planck constant. Planck constant having a value h is equal to 6.626 multiple 10 power minus 34 meter square kg per second. And c having a value 3 into 10 power 8 meter per second. When you will multiply both h and c, you will get some answer, and you will convert into electron volt, then you will get some answer. That answer will be 1240 electron volt. Okay, 1240 electron volt value of hc you can find. Okay, this is your work. Okay, so phi, what is the value of phi? 4.0 electron volt. So you can solve it. Whenever you will solve it, then you will get approximate answer 310 nanometer. So this is your final answer. So which option is correct? You can just check 310 nanometer. So 310 having a option A. So option having a right answer of this problem. So now we are going to discuss next question. Now we are going to discuss question number 5 from the same chapter, dual nature of radiation and matter. This question is a most important question because this question based on Einstein photoelectric equation. So please just read this question carefully. Question number 5. When the light of frequency 2 nu naught, where nu naught is a threshold frequency, is incident on a metal plate, the maximum velocity of electrons emitted is v1. When the frequency of the incident radiation is increased to 5 nu naught, the maximum velocity of electrons emitted from the same plate v2, the ratio between v1 to v2. What they are telling? They are telling if frequency is 2 nu naught, so velocity of electron is v1. If frequency increasing 5 nu naught, so velocity will be v2. So what is the ratio between v1 and v2? Here given 4 options. Which option is correct? We will see after solving this problem. As I told you that this question based on Einstein photoelectric equation. So according to Einstein photoelectric equation, you can write E is equal to W naught plus half mv square. Okay, so where E is a energy, so E you can write also E is equal to h nu, and W naught is also a form of energy, that is we can say that work situations. So we can write h nu naught. Okay, so now you can just find, you can just replace the value here. Two conditions. First, frequency given 2 nu naught. Okay, so velocity will be v1. If you are applying this first condition, it means first condition if you are applying, so how you can write this equation? You can write h 2 nu naught is equal to, you can write h nu naught plus half mv1 square. You can write like this. Now you can solve. 2h nu naught is equal to h nu naught plus half mv1 square. So now you can write 2h nu naught minus h nu naught is equal to half mv1 square. So finally you can write h nu naught, 2 minus 1, 1. H nu naught is equal to half mv1 square. So this is the first calculation. Okay, yes or no? When frequency will be 2 nu naught, so you will get this value. Similarly if you are applying Similarly, if you are applying second condition, means 5 nu naught, second frequency condition and second velocity condition, so you will write second equation. You can write here h 5 nu naught is equal to h nu naught plus half m v2 square. You can write. So similarly, 5 h nu naught minus 1 h nu naught, when you will remove this side, so you will get 4 h nu naught is equal to half m v2 square. So you will get second equation. So two equation you get. So now here v1, here v2. They are asking v1 to v2. If they will ask v2 upon v1, then you will divide this divided by this. But they are asking v1 to v2, so you will divide this divided by this. So now according to question, you can just find from equation first divided by second. So now you can divide h nu naught divided by 4h nu naught is equal to half m v1 square divided by half m v2 square. You can divide. So you know very well, h nu naught will cancel it, h nu naught will cancel it, half will cancel it, m will cancel it. So 1 upon 4 will be is equal to v1 square upon v2 square. So you can write like this simple form, v1 square upon v2 square is equal to 1 upon 4. So you can write v1 upon v2 is equal to 1 upon 4 power 1 upon 2. When you will solve this value, you will get v1 upon v2 is equal to 1 upon 2. So if you are writing in the ratio form v1 ratio v2, so you can write 1 ratio 2. So 1 ratio 2 is a final answer of this problem. Okay, so which option is correct? 1 ratio 2. Option D is a right answer of this problem. So future doctor, I want to say you that just please make a practice at your home behalf of like these questions. I solved the 5 question in this video. You will try to solve another types of question. That questions may be similar, either you can try as you know. Okay, if you have any query, any problem, so you can just make a comment below the comment box. I am always ready to help you. Thank you so much. We will meet in next lecture.